Okay. So hello everyone. Welcome to VITMAS Presents TechSum. So in this event, we can figure out how to have fun with mathematics using TinkerCad, which is an essential tool for electrical students. So first, we'll discuss the first topic of the webinar, which is the Arduino UNO board. Now, before understanding what an Arduino UNO is, we need to know what a microcontroller is. So a microcontroller is a small computer. It contains one or more CPUs or processor cores, along with memory and programmable input or output peripherals. So an Arduino UNO is a microcontroller board, which is based on the ATmega 328P or 8-bit microcontroller brain of board. It has 14 digital input or output pins, out of which 6 can be used as PWM outputs, 6 analog inputs, a 16 megahertz ceramic resonator, a USB connection, a power jack, and a reset button. Now, so on your right, you can see the basic schematic of an Arduino UNO. So as I mentioned earlier, there are 14 digital pins, out of which 3, 5, 6, 9, 10, and 11 are PWM pins. There are 6 analog pins here and some power supply pins where you can use both 5 volts and 3.3 volts. And on the left is the original diagram or the original photo of the Arduino UNO. So coming to Arduino IDE. So the Arduino Integrated Development Environment is a cross-platform application that is written in functions from C and C++. It's used to write and upload programs to Arduino-compatible boards. So this is the software where you have to type in the code in order to perform the project. Now, finally coming to TinkerCad. So the main purpose is to run simulations, and since hardware implementation can be quite difficult, TinkerCad can be used to design circuits, but it does have some limitations, such as it does not have all the components required, and obviously doing it physically is more helpful, but this is the best we can come up with, and it's quite versatile. So that ends the PPT. I will move on to a demonstration. So thank you. So I will do the basic demonstration on TinkerCad. So please let me know if you can see my screen again. Okay. So now I'm going to perform a basic circuit before I get onto the actual project. So you can use TinkerCad by just this drag and drop method. So we have a resistor, an LED, and a 9-volt battery. Now I'm going to perform a basic circuit to show you how TinkerCad works, and then we'll move on to the main project. So firstly, I'm going to connect the cathode to the second terminal of the resistor, the terminal 1 to the negative of the battery, and anode to the positive. So once I start the simulation, you can see that the LED will glow. And there it is. So this shows that the circuit is complete and we've successfully completed it. So now I'll move on to the actual project. So this didn't require a code, but the next one does. I shall demonstrate the project to you, and then we will move on to the code. All right. So now let's look at some basic components here. So we have, so this is going to be an MCQ based, so you'll be having 3 questions, and all of them will have MCQs. So we have option A and option B, and accordingly, so if your answer is correct, the green bulb will glow, and if it's wrong, the red red LED will, and you will also hear a buzzer at the same time. So let's start off with all the right answers. These are basic board mass and linear equation questions, which we can do very easily. So I'm starting the simulation. So first question, 3 times 6 plus 116. So we know that 3 times 6 is 18. So plus 116 is 134. So that's option A. So I'm going to click on option A. And as you can see, the green light shows that it's correct. Now, second question, 100 by 25 times 25 is 100. So which is option B. And I'll click on option B. Again, green light showing that the answer is correct. Now finally, the third one. So we have minus 3 plus 2x is equal to 11. So therefore 2x equal to 14, therefore x equal to 7, which is again option A. So I click on option A. Green light showing that it's correct. So now let's have some fun with it and let's put all the wrong answers and let's see what happens. So I'll stop the simulation for now and I'll start it again. Okay. So earlier we knew that the answer was 134. Now let's try 136. So red light and the buzzer. Next question. So earlier the answer was 100. Let's try putting 110, which is option A. Same thing again. And similarly, the third one. This time let's put option 9 since earlier the answer was 7. Same thing again. And you'll get a 0 out of 3. So this time let's put 2 correct answers and 1 wrong answer. I'll stop the simulation for now and start it again. So 134 was the correct answer as we discussed before. So I'm going to do that again. Green light showing that it's correct. Next one. The answer is 100. So let's put 110. So that's option A. Wrong answer. And for the third one, the correct answer is 7. Again, option A. So let's do that. Green light showing that it's correct. And hence 2 out of 3. So that ends the basic demonstration of this project. Now, this project requires a code. So I'm going to hand over this to my friend Orko Provo, who's going to explain the entire code to you, since he's the brains behind it. So I shall be sharing for now, and he'll share soon.
Thank you, Aishira, for the beautiful demonstration. Now I will explain the code. My screen is visible, right? 1 minute. Is it visible?
Yeah, it is.
Okay, thank you. So now I am coming to the code. So this is the code behind this project. So at first, in the first line, we can see here I am including a library. So basically, if we want to use any component with our Arduino, then for some components, we have to include their specific libraries. And here, as we are using LCD, then we have to include this library, which is liquidcrystal.h. So by using this library, then we will be able to use the functions related to the LCD. And in the second line here, liquid crystal LCD. So here we are defining this variable, which is LCD, and the type of the variable is liquid crystal type. And here we are defining this function liquid crystal and some pin numbers. So these all are the pin numbers. So basically, the first one, it is for the RS pin. The second one, it is for the enable pin. And this is for the D4, D5, D6, and D7. And now the display can be controlled by using 4 or 8-bit data lines. But here I am using 4-bit data lines. So here we can see from DB0 to DB7, these are the data bus. And here, so as we are using 4-bit data line, so we are not connecting DB0, DB1, DB2, DB3, this is all, but we are connecting DB4, DB5, DB6, DB7. And now, and here in the third line, we are declaring some counter variables, and I'm initializing the values also. And now I'm coming to the main code. So basically, if we want to run our code for the only for one time, then we have to write the code and this void setup. So there is the another function which is pin mode. So basically, if we use this pin mode, then we can specify the behavior of the mentioned pin. As here I'm writing like pin mode 11 comma input. So which means that this 11, the digital 11 pin will be acting as an input pin, and if our pin is acting like an output pin, then we have to write in this way pin mode 10 comma output. And here, as this is the connections, like For the button A, it is connected with the pin number 11. For the B, it is connecting with the pin number 12. And in this way, these all are the connections. And now there is another one function. So this is digital write. So basically, if we like when we want to write a high or low state value to our digital pin, then we use this function. So as we are writing digital write 13 comma high, so we are assigning the high value to the 13. And now coming to the most important command, which is lcd.begin 16,2. Like in our project, we are using a 16 cross 2 LED, which means it has 16 columns and 2 rows. So before starting the LED, we have to write this command, and we should keep in mind that this command needs to be called before any other command or if before any other library commands. And basically this command is used for initializing the interface and the dimensions like the rows and columns of our LCD. And now I'm coming to the next part. So this is set cursor. So basically the first one, this first, we can see 2 digits. So the first digit, it is the column number, and this is the row number. So when we are writing this, then we are repositioning our cursor. So when we are writing set cursor, then we can see that our cursor should be in the first position, like the top leftmost position of the LCD board. And in this way and as we know, like for the normal coding also, we use printf or cout for printing some messages, and here also lcd.print will print this message in the display. And here for the lcd cursor 0.1 sorry 0 comma 1, so the cursor should be there. And here also I am using another function, which is delay 5000. So basically for delay, it pauses the program for some certain amount of time, and we have to give the time as a parameter of the function. So as we are giving 5000, so this means this is in millisecond. So the program, we can see the display for only 5 seconds. And now I'm coming to the next part, like for the and before starting the actual display things like the problems and the options, so we should clear our LCD, right? So for this reason, we are LCD, like we are using this lcd.clear, and this function is mainly for clearing the LCD screen and repositioning the cursor in the upper left corner. So this is the void setup part. And now I am coming to the void loop part. So basically, if we want to run our code again and again, then we have to use this void loop part, and we have to write our function inside this void loop part. And here we can see here I have defined these 2 arrays, which is of string type. And in the first array, we have the questions, like the basic questions that we have seen before, these questions. And for the simplicity, we are using only 3 questions, but we can increase the number easily. So and here we can see the options for the questions. So now, like at first in the code line number 3, we are initializing this value like d equal to 0. So for the first one, when d equal 0, for printing the first question, we are writing again the lcd.set cursor, and then we are printing the problem 0, which denotes this problem. And this is problem 0, problem 1, problem 2, solution 0, solution, and solution 2. So we are printing the first problem, and in the second line we are printing its options. So now I'm coming to the next part. Like now here there is another function, which is digital read. So basically the digital read function is used for reading the state. So when I'm writing like int c equal to digital read 11, so we can see, if we see our schematic, then we can see the option A button, like which is the first button, it is connected with the pin number 11. So it will read the state of the button. Like if we press this button, then the C value will be high or 1, or if we don't press the button, then the value will be low or 0. So now this is the condition, like I'm initializing the value like C for the counting, for storing the state of first button, and W for second button. So as we have seen that the for the first question, the correct option was option A. So C value should be high. So when if C equal high, so it denotes that our option is correct. So for this reason, we are writing again a digital write 10 comma low, which means our red LED should not glow, and this is for the green LED. And when we press the correct option, then we can see our green LED is glowing. And here also we are again defining this delay, so we can see the glowing LED for 5 seconds only. So we are writing like this. And in the line number 48, C1 equal to C1 plus 1. So basically this is the counter which will count the number of total correct responses. And here also in the second loop I am defining C2, which will count the total number of wrong responses. And here D is the counter variable which will count the response. Like if we press correct option or we press wrong option, so we have given one response, right? So for this reason, we are using this counter that will count the responses. So at first we can see the D value was 0, and now after one response, our new D value is 1. So when D equal 1, then we are coming to the next part. And here also, like if we when we press any of the buttons, then the value will be changing, right? So for this reason, C equal to low and W equal to low, and by using these lines I am resetting our button state. And in the second part, when D equal 1, same procedure is followed. Like at first I'm displaying the problem and then the option, and then I am storing the state. And here in the as we have seen in the simulation, for the second one the correct option was B. So here just we have to reverse the code. Like in the first code, like in the first part we see when C equal 0, because this is for the correct option. Now this option B is the correct. So for just we have to reverse this parameters. Like here W equal high, then each and everything is same like the previous one. And here also for the second response, and we have given another one response. So the D value is now 2. So at first it was D 0, then after one response it was D equal to 1, and now it is D equal to 2. And this is same for the previous one. Like this is for the wrong answer. So if we press the wrong answer, like if we press the option button A, then we can see the buzzer, like we can see the red LED and the buzzer will start buzzing. And now here also I am resetting the here also I am resetting the pins, our button states. And same procedure is followed in the for the third question also. For the simplicity of the code, I have written this code in this manner. So we can do, like we can use the loop and all, but I have written in this manner to for the simplicity of the code. So here also when the third question, like when the D value is 2, then we can show like we can show the third question in the by using this LCD. And here in the last case, like we are also then again we are resetting the button state. And when we have submitted all the three responses, then the final D value is 3. Now this is the turn for the final result. So when we pray, like when we show D equal 3, then this is the code for printing the final answer. Like this is in the first line, we can say we can see the score, and in the 7,0 it means the cursor will be in the this position, like 0 to 7, like seventh column, and zeroth row in the upper position here something. And so here somewhere here and here, so we can, and as we are storing the value of correct responses in the variable C1, so we are printing this C1. And and then in the second line we are printing this greeting message, thank you. So this is all about the code. I hope you all have understood it properly. If you have any doubts, then you can ask me. Otherwise, this is the code of behind this project. So, okay, guys, thank you. Thank you for listening.
Thank you so much, guys, for attending this session and for taking your time. And hope to see you guys at the next event as well. Yeah. Bye-bye.
Thank you for coming. Bye.